Horsepower is a unit of measurement of power. There are many different standards and types of horsepower. The term was adopted in the late 18th century by Scottish engineer James Watt to compare the output of steam engines with the power of draft horses. It was later expanded to include the output power of other types of piston engines, as well as turbines, electric motors and other machinery. The definition of the unit varied between geographical regions. Most countries now use the SI unit Watt for measurement of power. With the implementation of the EU Directive 81/81 EEC on January 1, 2010, the use of horsepower in the EU is permitted only as a supplementary unit. Definitions of term units called horsepower have differing definitions. The mechanical horsepower, also known as imperial horsepower, of exactly 550 foot-pounds per second is approximately equivalent to 745.7 watts. The metric horsepower of 75 kilograms force m per second is approximately equivalent to 735.5 watts and 98.6% of an imperial mechanical horsepower. The Förderstarke PS is a name for a group of similar power measurements used in Germany around the end of the 19th century, all of about 1 metric horsepower in size. The boiler horsepower is used for rating steam boilers and is equivalent to 34.5 pounds of water evaporated per hour at 212 degrees Fahrenheit, or 9,809.5 watts. 1 horsepower for rating electric motors is equal to 746 watts. Continental European electric motors used to have dual ratings, using a conversion rate of 0.735 kilowatts for 1 horsepower. British Royal Automobile Club horsepower is one of the tax horsepower systems adopted around Europe, which make an estimate based on several engine dimensions. Measurement. The power of an engine may be measured or estimated at several points in the transmission of the power from its generation to its application. A number of names are used for the power developed at various stages in this process, but none is a clear indicator of either the measurement system or definition used. In the case of an engine dynamometer, power is measured at the engine's flywheel. Also, with a chassis dynamometer rolling road, power output is measured at the driving wheels. This accounts for energy or power loss through the drivetrain inefficiencies and weight thereof, as well as gravitational force placed upon components therein. In general, nominal or rated horsepower is derived from the size of the engine and the piston speed and is only accurate at a pressure of 48 kilopascals, indicated a gross horsepower minus frictional losses within the engine, equals brake net crankshaft horsepower minus frictional losses in the transmission, equals shaft horsepower minus frictional losses in the universal joint per second. Differential wheel bearings, tire and chain, equals effective. True are commonly referred to as wheel horsepower. All the above assumes that no power inflation factors have been applied to any of the readings. Engine designers use expressions other than horsepower to denote objective targets performance, such as brake mean effective pressure. This is a coefficient of theoretical brake horsepower and cylinder pressures during combustion. Nominal horsepower. Nominal horsepower is an early 19th century rule of thumb used to estimate the power of steam engines. For paddle ships, the piston speed was estimated as 129.7 by 1/3.35. The stroke was the distance moved by the piston. For the nominal horsepower to equal the actual power, it would be necessary for the mean steam pressure in the cylinder during the stroke to be 48 kPa and for the piston speed to be of the order of 54 to 75 meters per minute. The French Navy used the same definition of nominal horsepower as Britain. Indicated horsepower. Indicated horsepower is the theoretical power of a reciprocating engine if it is completely frictionless in converting the expanding gas energy in the cylinders. It is calculated from the pressures developed in the cylinders, measured by a device called an engine indicator, hence indicated horsepower. As the piston advances throughout its stroke, the pressure against the piston generally decreases, and the indicator device usually generates a graph of pressure versus stroke within the working cylinder. For this graph, the amount of work performed during the piston stroke may be calculated. Indicated horsepower was a better measure of engine power than nominal horsepower because it took account of steam pressure. But unlike later measures such as shaft horsepower and brake horsepower, it did not take into account power losses due to the machinery internal frictional losses, such as the piston sliding within the cylinder, plus bearing friction, transmission and gearbox friction, etc. Brake horsepower. It is the measure of an engine's horsepower before the loss in power caused by the gearbox and drivetrain. In Europe, the DINT standard tested the engine fitted with all ancillaries and exhaust system as used in the car. The American SAE system tests without alternator, water pump, and other auxiliary components such as power steering pump, muffled exhaust system, etc. So the figures are higher than the European figures for the same engine. Brake refers to the device which was used to load an engine and hold it at a desired rotational speed. During testing, the output torque and rotational speed were measured to determine the brake horsepower. Horsepower was originally measured and calculated by use of the indicated diagram, and later by means of a prony brake connected to the engine's output shaft. More recently, an electrical brake dynamometer is used instead of a prony brake, although the output delivered to the driving wheels is less than that obtainable at the engine's crankshaft. A chassis dynamometer gives an indication of an engine's real-world horsepower after losses in the drivetrain and gearbox. Shaft horsepower. Shaft horsepower is the power delivered to the propeller shafts of a steamship, or an aircraft powered by a piston engine or a gas turbine engine, and the rotors of a helicopter. This shaft horsepower can be measured with instruments, or estimated from the indicated horsepower and a standard figure for the losses in the transmission. This measure is not commonly used in the automobile industry, because in that context drivetrain losses can become significant. Wheel horsepower. Motor vehicle dynamometers are used which measure the actual horsepower delivered to the driving wheel, which represents the actual usable power levels available considering all losses in the drivetrain and all parasitic losses such as pumps, fans, alternator, etc. The vehicle is generally attached to the dynamometer and accelerates a large roller and power-absorbing unit which is driven by the vehicle's drive wheel. The actual power is then computer calculated based on the rotational inertia of the roller, its resultant acceleration rates and power applied by the power-absorbing unit. Some motor vehicle dynamometers can also be purely inertia-based, where the power output is calculated from measuring the acceleration of a roller drum with a known rotational inertia and known parasitic frictional losses of the roller drum's bearings. Engine power test standards. There exist a number of different standards determining how the power and torque of an automobile engine is measured and corrected. Correction factors are used to adjust power and torque measurements to standard atmospheric conditions, to provide a more accurate comparison between engines as they are affected by the pressure, humidity, and temperature of ambient air. Some standards are described below. Society of Automotive Engineers, SAE International Early, SAE Horsepower. In the early 20th century, USA called SAE Horsepower was sometimes quoted for U. automobiles. This long predates the SAE horsepower measurement standards and was really just another term for the widely used LAM or NACC horsepower figure, which was the same as the British RAC horsepower, used for tax purposes. SAE gross power. Prior to the 1972 model year, American automakers rated and advertised their engines in brake horsepower, frequently referred to as SAE gross horsepower, because it was measured in accord with the protocols defined in SAE standards J245 and J1995. As with other brake horsepower test protocols, SAE gross HP was measured using a stock test engine, without accessories, and sometimes fitted with long tube test headers in lieu of the OEM exhaust manifolds. The atmospheric correction standards for barometric pressure, humidity and temperature for testing were relatively idealistic. SAE net power. In the United States, the term bhp fell into disuse in 1971–1972, as automakers began to quote power in terms of SAE net horsepower in accord with SAE standard J1349. Like SAE gross and other brake horsepower protocols, SAE net HP is measured at the engine's crankshaft, and so does not account for transmission losses. However, the SAE net power testing protocol calls for standard production-type belt-driven accessories, air cleaner, emission controls, exhaust system, and other power-consuming accessories. This produces ratings in closer alignment with the power produced by the engine as it is actually configured and sold. SAE certified power. In 2005, the SAE introduced SAE certified power with SAE J2723. This test is voluntary and is in itself not a separate engine test code but a certification of either J1349 or J1995, after which the manufacturer is allowed to advertise certified to SAE J1349 or certified to SAE J1995, depending on which test standard have been followed. To attain certification, the test must follow the SAE standard in question, take place in an ISO 9000-9002 certified facility, and be witnessed by an SAE-approved third party. A few manufacturers such as Honda and Toyota switched to the new ratings immediately. With multi-directional results, the rated output of Cadillac's supercharged Northstar V8 jumped from 440 to 469 horsepower under the new tests, while the rating for Toyota's Camry 3.0 L1 MZ V6 fell from 210 to 190 horsepower. The company's Lexus S330 and Camry Che V6 were previously rated at 225 horsepower, but the S330 dropped to 218 horsepower while the Camry declined to 210 horsepower. The first engine certified under the new program was the 7.0 LLS7 used in the 2006 Chevrolet Corvette Z06. Certified power rose slightly from 500 to 505 horsepower. While Toyota and Honda are retesting their entire vehicle lineups, other automakers generally are retesting only those with updated powertrains. For example, the 2006 Ford 500 is rated at 203 horsepower, the same as that of 2005 model. However, the 2006 rating does not reflect the new SAE testing procedure. as Ford is not going to incur the extra expensive retesting its existing engines. Over time, most automakers are expected to comply with the new guidelines. SAE tightened its horsepower rules to eliminate the opportunity for engine manufacturers to manipulate factors affecting performance such as how much oil was in the crankcase, engine control system calibration, and whether an engine was tested with premium fuel. In some cases, such can add up to a change in horsepower ratings. A road test editor at Edmunds.com, John DiPietro, said decreases in horsepower ratings for some 2006 models are not that dramatic. For vehicles like a mid-size family sedan, it is likely that the reputation of the manufacturer will be more important. DIN 70020 is a standard from German DIN regarding road vehicles. DIN testing, unlike SAE, tested the engine as installed in the vehicle, with cooling system, charging system and stock exhaust system all connected. Because the German word for horsepower is Verdienststarke, in Germany it is commonly abbreviated to PS. DIN HP is measured at the engine's output shaft, and is usually expressed in metric rather than mechanical horsepower. CUNA test standard by Italian CUNA, a federated entity of Standards Organization UNI, was formerly used in Italy. CUNA prescribed that the engine be tested with all accessories necessary to its running fitted, while all others, such as alternator, dynamo, radiator fan, and exhaust manifold, could be omitted. All calibration and accessories had to be as on production engines. ECER 24 is a UN standard for the approval of compression ignition engine emissions, installation and measurement of engine power. It is similar to DIN 70020 standard, but with different requirements for connecting an engine's fan during testing, causing it to absorb less power from the engine. ECER 85 is a UN standard for the approval of internal combustion engines with regard to the measurement of the net power. 81269 EEC 81269 EEC of 16 December 1980 is a European Union standard for road vehicle engine power. International Organization for Standardization ISO 14396 specifies the additional and method requirement for determining the power of reciprocating internal combustion engines when presented for an ISO 8178 exhaust emission test. It applies to reciprocating internal combustion engines for land, rail and marine use, excluding engines of motor vehicles primarily designed for road use. ISO 1585 is an engine net power test code intended for road vehicles. ISO 2534 is an engine gross power test code intended for road vehicles. ISO 4164 is an engine net power test code intended for mopeds. ISO 4106 is an engine net power test code intended for motorcycles. ISO 9249 is an engine net power test code intended for earth-moving machines. JISD 1001 is a Japanese net and gross engine power test code for automobiles or trucks having a spark ignition, diesel engine, or fuel injection engine.